So something that's very helpful actually is if you're given the quadratic formula, which actually while you're doing assignments for this, you should write out as much as possible so that it increases the probability you'll actually remember it. Negative b plus or minus square root of b squared minus 4ac over 2a. There's actually something really special going on here, which is this number right here. Okay, the number under the square root sign. And this number here is called the discriminant. Discriminant. Fun to spell. Even funner to say. So you've got the discriminant. Now, the thing that the discriminant is useful for is being able to kind of determine ahead of time what your solutions are going to be. So, in general, for the quadratic formula, if I have something like 3x squared plus 2x, I don't know, plus 1 minus 1 equals 0. Okay, I have absolutely no idea what the answer to that is. I suppose I could figure it out if I wanted to. Yeah, I guess I could. But in any case, sometimes it's helpful to know ahead of time whether you're actually going to get an answer. So you basically have three options here. If I was going to solve this, I would literally plug in everything for B, or everything for A, B, and C. So this would be A, this would be B, and this would be C. So A would equal 3, B would equal 2, and C would equal negative 1, right, because it's a minus. So if I was going to plug this in, I get negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Okay, which is all well and good, and it's literally, once you've got it down, it's just a plug and chug issue. So 4 plus 12 over 6. So eventually I would come up with the square root of 16. So anyway, so I go on like that, etc. Well, I guess I can go ahead and work it out for you. So at this point I'm going to break it up into two solutions. Negative 2 plus 4 over 6, or negative 2 minus 4 over 6. So I'd get, what is that? 2 over 6, or negative 6 over 6. So either 1/3 or negative 1. Okay. Now the way that we would classify this is that I could say that given these answers right here, I have two real solutions. Okay? Which means, thank you. Two real solutions. Which means that if this was, say, a problem related to length or time or velocity or real values, that I would get a legitimate answer. So that's kind of nice to know. Now that isn't always the case. So say I would plug this in and say I had a problem that looked more like this. X squared, I don't know, plus 3x plus 10. How about that? Alright, now again, plus or minus the square root of b squared minus 4ac all over 2a. So remember I have a, b, and c. b is 3, c is 10. You know what do you suppose a is? A is 1, right? Because there's a secret coefficient of 1 out front. Okay. So if I go plug these in, I have that x is equal to negative b plus or minus the square root of b squared minus 4 ac all over 2 times a. So I've got negative 3 plus or minus the square root of 9 minus 40, and that should immediately be ringing some alarm bells in your head, because I have the square root of negative 31 over 2. Now maybe you know how to deal with this, but maybe you don't. This is a major issue. Why? Remember why? They can't really take the square root of a negative number. Makes us go, ah! Okay. So, maybe you know how to deal with this and make it an I, maybe you don't. But what's important to recognize is that whatever answer we get, we're no longer going to get real solutions. When you start taking the square root of negative numbers, you get what are called imaginary solutions. So the answer to this question would be that we have two imaginary solutions. Okay? Fair enough? Now, could do you one better. I swear, I have a reason I'm doing all this, I promise. Say I have x squared plus 2x plus 1. Alright, so the x equals the negative b plus or minus the square root of b squared minus 4ac all over 2a. I swear I'm going to get back to why we care about this discriminant thing in a minute. So I have a, b, and c. A is going to be, remember, 1, b is 2, and c is 1. Thank you. There we go. Alright, so I'm going to plug these in. I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Now if I work this out, I've got negative 2 plus or minus the square root of 4 minus 4 all over 2. So negative 2 plus or minus the square root of 0, right? So I have negative 2 plus or minus, the square root of 0 is just 0 over 2. Now if you really want to get formal, you can break this out and you can say, okay, it's negative 2 plus 0 and negative 2 minus 0. But in the end, we know that that's going to come out, it's going to come out to the same thing on both sides. So really what we have here, one real solution. We have exactly one of the same thing. So sometimes people will say it's too repeated, but most of the time people will say that we just have exactly one real solution. Now, back to the whole purpose of this lecture is that it's really sometimes important to be able to know in advance if you're going to have these different kinds of solutions. So now, look back on your notes and take a look at what was here in this discriminant. So remember we said the discriminant is the thing that's under the square root sign. Here, when we had two real solutions, the thing under the square root sign was positive, which makes sense, because then it would give us some kind of a real number. Even if it had turned out to be like the square root of 6 or something like that, it's still a real number. It's just irrational, but I can stick it in my calculator and get an answer. So what we can conclude is if the discriminant is positive, so if the discriminant is greater than 0, that's going to give us two real solutions. I'm going to write this all out in a second again, but I'm just trying to make you see the connection. If I have a discriminant that is positive, I'm going to have two real solutions. Here, I have a discriminant that's negative. When my discriminant is negative, or less than 0, I have two imaginary solutions. Finally, if my discriminant is 0, then that means that I'm going to end up with exactly one real solution, right? Because I'm plus or minusing a 0, so I can't get two of anything. Whatever I get has to be just one of it, and since I'm not taking the square root of a negative number, it has to be real. So one of the things that they like to do when they're studying the quadratic formula is to take a look at this discriminant, b squared minus 4ac. Now, if this is greater than 0, we have two real solutions. that's too big. Sorry, let's fix that. Okay, is that good? I think that's good. Alright, so b squared minus 4ac is greater than 0. We have two real solutions. You don't have to memorize this, just to think, well, if they take the square root of a positive number, I'm adding and subtracting two different things, or I'm adding and subtracting stuff, so I'm going to end up with two different answers. If it's equal to 0, I'm going to have one real solution. And that's, again, because I'm taking the square root of 0, I'm adding or subtracting nothing. So I'm only going to have one solution. Then if it's less than 0, I'm going to have two imaginary solutions. And again, that should be pretty easy to remember because they're imaginary. You're taking the square root of a negative number, so you're not going to get a real answer. So these two on the top are going to give you real solutions because you're taking the square root of a positive or non-negative number. The second one is just going to give you imaginary solutions. Okay? So this is generally something you're going to see questions made of, you know. Given the following, what kind of solutions would you expect? And so, in fact, this is a way to give you questions about the quadratic formula without making you do the entire quadratic formula every single time. So, a couple of ways that they can make these problems hard on you is to, really the only way they can make this problem hard on you is to put things in a different order. So if they had something like this, and then they said, you know, determine the characteristics of the solutions, or something like that, all you would really need to do to solve this problem is to go in and put it in the right order. So since the 5x is already positive, I would probably move everything to the other side, and I'd end up with something like 5x squared minus 3x minus 6 equals 0. Now, if it's asking for the type of solution that you're going to get, the only thing that you have to calculate is b squared minus 4ac. So I've got a, b, and c. A is 5, b is negative 3, and c is negative 6. So I have negative 3 squared minus 4 times a times c. So I have 9 plus, whatever that is, 20 times 6 is 120. So 129. So I would look at that and I'd say, okay, that's greater than 0. So according to my little chart up here, and according to the analysis that we just did, that means I have two real, looks weird, real solutions. Okay? That's about as bad as they can make it. Or they could put fractions in there, I guess. If you have a problem that has fractions, like, say I had something like, I don't know, 1/5 equals 1/20 x squared plus 5, I don't know, fourths in general. Remember that you can multiply an entire equation by a number, so that's probably what I would do, is I would multiply both sides of the equation by something to get rid of that fraction, and the something I would choose would probably be 20. So I would do that before I even did anything else, because I just don't want to mess with fractions. So over here on the left, 20/5 would be 4. Those 20s would cancel out, and then, remember, I distribute that across. So 20 divided by 4 is 5, times 5 is 25. So however you want to get there, I would much rather solve this problem than the one on the line previous to it. Okay, and then again, you just want to move everything to the same side of the equation. And then assign A, B, and C from there. So A, B, and C. A is 1, B is negative 4. That's also a pretty common mistake, is to forget to include that negative there, so make sure you're paying attention to that. So I've got B squared minus 4AC. Forgetting to put the B squared into parentheses, so you should always have a positive number there. Minus 4 A, C. So I've got 16 minus 100, which is, what, negative 84, I think? It doesn't really matter what specifically it is, because I know that it's negative. And since it's negative, again, I know I have two imaginary solutions. So aside from this, all they can ask you to do is actually go ahead and plug it into the quadratic equation and get actual answers, and that will be subject of something else. But this is just for using the discriminant to figure out how to find what kinds of solutions you're going to get. Sometimes it's like characterize the solutions or something like that, but this is what we're going for.